Hmm. And that's finished. And now onto the real stuff. Finding zeros of polynomials. Okay. So the first function is a cubic, and we are to find the zeros of this cubic. Okay. So what does the rational root theorem tell us? It tells us to pay attention to the 18 on the end and the 2 at the beginning, right? And it says something like 18 over 2, all the factors of 18 over 2 are potentials. I think it says something like that. So I'm going to try that out. So 18 over 2 is 9. So the factors of that are 1 and 9, and 3 and 3. And of course, the positive and negative combinations of these. So I'm just going to try 1. I'm going to try 1 and then negative 1, because they're simplest to do. So if I try 1, I get 2 minus 13, which is minus 11, plus 3, which is minus 8, plus 18, which is 10, which does not work. If I try minus 1, then I get minus 2, minus 13, minus 3, which is minus 18, plus 18, which does work. So I think this was 10, right? So that works. So x plus 1 must be a factor. So now I'm going to use synthetic division to divide through by x plus 1. So the coefficients are 2, negative 13, 3, and 18. So I put them there just like that. And I put the negative 1 right here. And then I just do synthetic division. Okay, so 2 is going to be down here. Then negative 1 times 2 is negative 2. And we add downwards. So we get negative 15. And negative 1 times negative 15 is 15. So we add downwards and we get 18. And negative 1 times 18 is negative 18. And we add downwards and we get 0, which is what we expect. And then these numbers right here will tell us the coefficients of the quadratic that we are looking for. So f of x can now be rewritten as x plus 1 multiplied by, now we're going to get the quadratic, 2x squared minus 15x plus 18. Now, can that quadratic be factored? Yes or no? Well, don't forget, we can always we can always use the discriminant, b squared minus 4ac. And that can test if something can be factorized or not. So negative 15 squared is 225 minus 4 times 2 times 18. And what is 8 times 18? Well, that's 144. And what's 225 minus 144? Well, that's 81. Oh, so that's a perfect square number. And therefore, this can be factorized. So I just have to think about it for a little bit, and maybe I'll be able to do it. Pardon me. Okay, so 2x in my first bracket and x in my next bracket. So because it's 18, and I have to somehow make negative 15 out of that, so it's going to have to be 2 negative factors of 18. So what am I going to try? I'm going to try a negative 6 and 3 and negative 3, just like that. And when you expand it out, you can see that it works. It works. And now that we've factorized f of x, we can say what the zeros are. The zeros are negative 1 from the first bracket, 3/2 from the second bracket, and 6 from the third bracket. And we must check our answer and make sure that it's correct. So you see here they did the technique that I did. They paid attention to 18 and 2 and did 18 divided by 2 to get the possibilities. And there are a lot of possibilities. 18. Okay. Yeah, okay, so they tried negative 1 first. Well, that was pretty darn lucky, right? They tried negative 1 first. Okay, and let's see. Okay, and then they ended up in the exact same place that I did. Okay, so that's good. And now problem 2, trying to find the zeros of this polynomial here. So the possibilities are 1 and 4, or 2, 1, 2, and 4, and then, wait, let me think. Okay, plus or minus 1, plus or minus 2, plus or minus 4. So that's like 6 possibilities, right? I would think. So I do the easy ones first because they're easy. So I'm going to put in 1. Okay, so 1, take 3, take 5 is minus 7, plus 3, plus 4 takes me to 0. Okay, so 1 is a success. Let me just check that one more time. 1 minus 3 minus 5 plus 3 plus 4 makes 0. So 1 is a success. And this implies that x minus 1 is a factor of px. And so let's divide this. Let's divide px, the big polynomial here. Let's divide it by x minus 1. Just like when you factorize an ordinary number, you divide it by what you have so far, and you keep on breaking down the number. Okay, so I'm going to use synthetic division. So here I go. So I get the coefficients, which are 1, -3, -5, 3, and 4. And then I grab this 1 right here, and I put it right there. Okay, so begin synthetic division. Okay, I begin by putting a 1 right there, and then I do 1 times 1 and put it there. And then I add straight down. -3 plus 1 is -2. And then I do 1 times -2, and I put the answer right there. And then I add straight down. -5 minus 2 is -7. And then I do 1 times -7, and I put the answer right there. And then I add straight down. 3 is -4. And I do it one more time. 1 times -4. I put the answer right, and I go down, and I get 0, which is exactly what I was expecting. Because it goes into it, I should get a 0 as my remainder. So now, p of x can be written as x minus 1, and then open brackets, and we're going to write a cubic. We're going to write a cubic next. So it's going to be x cubed minus 2x squared minus 7x minus 4. Okay. Now I want to factorize that cubic right there. So I'm going to do exactly the same reasoning again. So I'm going to try. If I put in 1, it doesn't work because I don't get 0. But if I put in -1, let's see what happens. Okay, -1 cubed is -1. And then here, that will turn into -2. That will turn into +7. And that will turn into -4. That's when I put in -1. And this adds up to 0. And therefore, because -1, putting it in here gave me 0, that means that x plus 1 is a factor of that cubic. So x plus 1 is another factor. And what I'm going to do is I'm going to divide that cubic right there by x plus 1 using synthetic division. So here I go. So I grab the coefficients now, the 1, the -2, the -7, and the -4. 1, -2, -7, and -4. And here I grab the -1. You remember that synthetic division only works when you're dividing by something which looks like this. And this is a plus sign right here, so I have to put a -1 right there. Okay, and now I just go ahead and do it. So I've got a 1 right there. Now -1 times 1 is -1, and I add straight down to get -3. -1 times -3 is 3. I add straight down and I get -4. And -1 times -4 is 4. And I add straight down and I get 0, just like I expected. Just like I expected. So Px can be, I can write it down as x minus 1 times x plus 1. And now I'm about to write down a quadratic. And it will look like x squared minus 3x minus 4. And can that quadratic be factorized? Yes, it can. Here's the answer. So, what does this mean? This means the zeros of p of x, if I just peel them straight off the factors right here. Wait, I didn't write that correctly. That should be a minus sign. Okay. The zeros are +1, -1, and 4. What should I say about this -1? What you say is this has a multiplicity of 2. Multiplicity of 2. And what that means is it affects how the graph of the polynomial looks. It affects how the graph of the polynomial looks. On the graph, this polynomial will touch the x-axis at these numbers 1, -1, and 4. But it will touch this number exactly once, like that. It will not cut straight through. It will just touch it just once, like that. So anyway, let's check and see if I'm speaking correctly. Check to make sure that I'm not saying a bunch of rubbish. Okay, that's correct and that's good. That's correct and that's good. Okay, now comes problem 3. Problem 3. So this is a polynomial with degree 4. So it's huge. And 24 divided by 2 is 12, which has many factors, many plus and minus factors. So I have to get a move on, and I have to check these. So I'm just gonna do it. Okay, I'm gonna try 1. So 2 minus 7 minus 2 is -7. -7 plus 28 is 21. And 21 minus 24 is -3. So 1 does not work. Keep track of which ones do not work. What about -1? Okay, that will give me 2 plus 7, which is 9, minus 2, which is 7, and then 7 minus 28 is minus 21, and minus 21 minus 24 does not work. So that does not work either. Okay, and now I guess I have to try 2. This is a lot of checking. Okay. Oh, wow, this is going to be a lot. All right, I have to try. Okay, that is 32. Take 56. Take 8. Plus 56. Take 24. Okay, so I can see these cancel. That's good. It's 24, and 24 minus 24 is 0. So good. So 2 works. So what does that mean? That means that x minus 2 is a factor. And now I'm going to divide that gigantic polynomial by x minus 2 using synthetic division. So here I go. Okay, so a 2 should be right there. That's my first thing that I do. Okay, now 2 times 2 is 4. And add them together, and I get -3. 2 times -3 is -6. And add them together, and I get -8. 2 times -8 is -16. Add them together, and I get 12. 2 times 12 is 24. Add together, and I get 0, just like I expected. So now AX can be written as this guy. So let's see. Let's see now. So now I'm going to factor this cubic. So what are possible factors of it? Well, 12 divided by 2 is 6. And that has 8 factors. Like if you do the plus or minus thing, it has 8 factors. Yeah. So I just have to try things out. So I'm going to put 1 inside and see what happens. So I get 2 minus 3 minus 8, which is -9. And -9 plus 12 is not 0. So 1 does not work. And if I do -1, I get -2, -3, plus 8 plus 12, which does not work as well. That does not work. Okay, now I'm going to try 2. But I have to write things down. So 2 times 2 cubed, take 3 times 2 squared, take 8 times 2 plus 12. That would be 16. Take 12, take 16 plus 12. And because these cancel out and these cancel out, it must be 0. So 2 is a success. So it was a factor twice. X minus 2 was a factor twice. So now I'm going to use synthetic division, and I'm going to divide that cubic by x minus 2. So I put a 2 in that spot, and then 2 minus 3 minus 8 and 12 up here. And I do synthetic division, and I'm going to get this with 0 there, just like I wanted. Now our polynomial a of x can be written like this. Which is great, because now I just have to factor that quadratic. So I better try. So I'll put 2x there, and x there. And how do I make 1 using this? It will be through 3 and 2. So I add 2 and I take away 3 like that. And that works. So the zeros are 2, 3 over 2, and negative 2. And this 2 right here has a multiplicity of 2. And all the others have a multiplicity of 1. So now we check. Everything must always be checked. And that's correct. That's correct, and that's good. Okay, and yeah, now I've got to try the 4th one. G of x now I do not know. Well, how do you do this? Aha! What do I do? I'll just try some stuff. I'll try some stuff, then I'll read the notes again, and if I really am stuck, I'll have to look. So, first try 1. Okay, so we're going to have 8 and 36 and 46. I mean, 1 is obviously not going to work. Okay, so that's a no. Then try -1. Okay, so we're going to get -8 plus 36 minus 46 plus 7 plus 12 minus 4. And we get minus 10 minus 18 minus 18 plus 19 is 1, and 1 minus 4 is minus 3. So unfortunately, that's a no. So if 1 and minus 1 don't work, I need to read. Find the values of a and b if -2 and 2 are the roots of the polynomial x squared minus 4x plus ax plus b. Just do long division and divide it through by x minus 2 and then x plus 2, and then you'll get a pair of equations, and then you solve them simultaneously. That's what I would do. So let's see. Mm-hmm. 40 over 12. I see. Mm-hmm. Mm-hmm. Okay, this is 4. Are you kidding me? What? I'm not doing that. No, yes, I am. When we've got fractions, it's usually best to start with the integers and do these first. Okay, that's fine. They say plus or minus 9 over 2. I see. Okay. So they do a more economical synthetic division. They don't write down the intermediary results, but I can see what they're doing. First, they put the 2 there, and then they do negative 3 over 2 times 2, which is negative 3, and then they add it on to 1, and they get negative 2. So I see what they're doing. Okay, so I think I have enough knowledge to try it out. So here we go. Okay. So what's the space? All the factors of 4, 1, 2, and 4, divided by all the possible factors of 8, 1, 2, 4, and 8. Now that is a heck of a lot of things to try, I think. 1, 2, 4. Really, 24 possibilities. Well, though those can be reduced, though, because look, these are the same. 1 over 1 is the same as 2 over 2, which is the same as 4 over 4. So, it's still a lot. Anyway, just keep moving until you notice something. That's 2, that's 4. That's a half. That's 2. And so that occurs twice. That's a quarter. That's a half. That's an eighth. That's a quarter. That's a half. So it's not really as much as you're thinking. An eighth, a quarter, a half, 1, 2, and 4. And really right now, you've just simply exhausted 1. Right? And if you track the actual outputs, then you can use them to your advantage. Right? Like, what was the output when you put in 1? What was the output? Well, I don't know because I didn't write it down. So write it down. So here we go. So 8 plus 36 plus 46. That makes 90, and then 97, and then 97 minus 12 is 85, and 85 minus 4 is 81. So, because this is 81, and this is negative 3, There must be a root in between here. That's kind of garbage, though, because now I have to test these three. Right. Just get on with it. Okay, so I'm going to put inside a half. So a half to the power of 5 is 1 over 32, and 8 over 32 is a quarter. A half to the power of 4 is 1 over 16, and 36 over 16 is 18 over 8, which is 9 over 2. No, it's not. It's 9 over 4. And a half to the power of 3 is 1 over 8, and 46 over 8 is 23 over 4. A half squared is a quarter, so that's 7 over 4. And a half of negative 12 is negative 6, and then minus 4. So I get 40 over 4, which is 10, and 10 minus 10 is 0. So we found one. This is a success. So a half is a root. We found a root. So what does that mean? That means 2x minus 1 is a factor. And so now I'm going to divide by 2x minus 1 using synthetic division. But I have no experience dividing by a fraction, so this is my first time. So here I go. So 8, 36, 46, 7, negative 12, and negative 4. And I will know if I've done it okay if I get a 0 at the end. So here we go. So 8, and then half times 8 is 4, and add them. And a half times 40 is 20, and add them. That, and a half times 66 is 33, and add them. And a half times 40 is 20, and add them. And a half times 8 is 4, and add them, and we get 0, so that is good. So now g of x can be written as this. Or so I believe. 2 is a factor of everything here. Huh? What? This can't be correct. Because if I do 8 divided by 8, I get plus or minus 1. And I've already tried them. Did I make an error? So there's only one way to find out. I have to multiply everything again. Okay, so first I'm going to multiply everything by 2x, and then everything by negative 1, and then I'm going to add it together, and I'm going to see if I get the original polynomial. So here I go. So 16x to the 5. No, that's already a failure. Look, that's not correct. That's not correct. Do you know what's really incorrect? This. This is obviously wrong. It's just obviously wrong. Is it? Yeah, I know why it's wrong. I know that it's wrong, but like, well, how are you supposed to do it then? You have to like do it backwards or something like that. You know what? Forget synthetic division. I hate it. I'm going to do long division. So, yeah, I know it takes longer, but it's what I know how to do. And I want to actually defeat this polynomial. So here I go. Right, 2x into 8x to the 5, that's 4x to the 4, so write it there. And times it. And take it away. And divide it. And times it. That should be a minus. And take it away. And bring it down. And divide it. And times it. And take it away. And bring it down. And divide it. And times it. And take it away. And divide it. And times it and bring it down, and that should divide fine. So there you go. So, man, I really have to learn synthetic division better than what I've been doing, but hey, at least I have some technique. So 2x minus 1 is a factor, and this is another. And I'm realizing that essentially everything was just doubled because of this 2 right here. I realize that now, and so that was my error. And so now, wait. Yeah, that's fine, isn't it? Oh man. So how are you supposed to do this? Minus 20, minus 20, minus 40, minus 40. 37, 41, 41 minus 40. Nothing. I'm completely stuck. How does one do this? What if it has no factors? It's possible, because it's a quartic, and therefore it could be floating above the x-axis like that. Oh no, you fool! It's not just plus or minus 1. Goodness me, I don't even understand the rational root theorem. 4 to 1 over this. Oh goodness. That's what it is. So it's 9, basically 9 possibilities, something like that. Okay, so I have to do it all over again. I'm going to defeat this this polynomial, but it's a signal that I need to get a lot better at this. So not as many possibilities to try as what I'm thinking. Okay, so you know what? If you look at it, obviously only a negative number is going to work. Only a negative number is going to work. And we've already tried -1. So because integers are easier, we're going to try -2 and then -4. That sounds good. So first I'll try a -2. But I want to keep track of everything. So there. Okay, let's do this. So 4 times -2 to the 4 plus 20 times -2 cubed plus 33 times -2 squared plus 20 times -2 plus 4. And that gives 64 for the first thing. -160 for the next thing. 132 for that. -40 for that, and 4 for that. And when you put them together, it does give you 0. That's wonderful. All right, so we have another x. Well, I just tried -2, so the factor must be x plus 2. So okay, so I'm going to synthetically divide that thing, that quartic, by x plus 2. So I put a -2 there, and I'm going to do 40, 4, 20, 33, 20, and 4. And here we go. 4 in that spot right there. -8 there. 12. -24 there. 9. -18 there. 2. And -4 there. And 0. Just like we expected. So the polynomial has been updated. It is now 2x minus 1, x plus 2, and this thing here. Wait, no, that's fine. That's fine. Oh, no. No, no, no. No, 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 no. It's a cubic. It's a cubic. It's a cubic. 4x cubed plus 12x squared plus 9x plus 2. Getting very close. You know, it would be good if I kept track of what I've already tried. So 1, -1, they both did not work. Half did work. Could work again, potentially. -2 did work. And all of it is positive. So it would be good if I only tried negative numbers. And it's a smaller space to search through now. So first, I will try. Just put in -1. Just see. Just see. No. Okay, just making sure. Now try -2 again. Try -2. You have to write things down. And what do I get? -32 plus 48, which is 16. 16 minus 18 is -2, and -2 plus 2 is 0. So we have another root. This is awesome. All right. So how am I going to do this? Now I'm going to synthetically divide that thing there, that cubic, by x plus 2. So I'm going to write a -2 there, and then a 4 and a 12 and a 9 and a 2. And here I go. 4. Wait, is this right? Oh, yes, it is. Okay, so now my polynomial looks like 2x minus 1, x plus 2 appearing twice, followed by this quadratic. And this quadratic, if I do the discriminant, and I'm just going to feed in the numbers now. So 16 take away 4 times 1 is 0. Oh, so that means it's a perfect square. So I don't know why I didn't see that before, but whatever. There. So the roots are -1/2, -2, and -1/2. That occurs once. That has a multiplicity of 1. That has a multiplicity of 2. And that has a multiplicity of 2. And now to check. That's awesome. This problem was very long and messy. Good. They agree with me. But I'm very happy. So I'm going to save it to my notes folder. And then I'm going to move to the next thing. So what do you have for me now? Partial fractions. Okay, so yeah, I'm going to brush my teeth. Maybe I'll do this, maybe I won't. Be well, be well.